So, good evening, guys. Good evening. I guess it's visible, right? The page is visible, like I mean the board is visible, right? Yeah. Yeah, the board. Okay, fine. So, a very good evening, guys. Good evening to one and all who are watching in online, and the students are present in offline also. Okay, so up to now we have doing topics on 100 days challenge and then previous year questions. Yes or no? Like apart from that, we are going to start with the IPE session also, right? So I have given the blueprint of the AP as well as Telangana IPE examinations for physics. So in that, the topics has been listed out like a very long answer question, long answer question, short answer question, and very short answer questions. Like long answer in the sense in your word it's essay questions will say, right? So that's the thing, right? So we'll start with the 11th, that is inter first year of long answer question, that is essay type questions. So with work, energy and power. So in that we are going to see the three important long answer, that is essay question, right? The first question in that, yeah, this is the first question. Develop the notation of work and kinetic energy and show that it leads to work energy theorem. So when we start reading the questions, right? Yeah, wait a minute, it's getting black. No, I'll adjust it. Yes, it's fine, I guess. Fine, right? Yeah, thank you. So it's fine, absolutely fine now. So when we are talking about any question, right? So we should be know the terminologies, whatever the whatever the words used in the questions. The terminologies used is here. The first thing they have mentioned is work, right? Work, and then kinetic energy, work, kinetic energy, and then what is work energy theorem. So three terminologies I need to know first, and then if we know what is the definition of the terminologies, easily I can analyze and write the questions properly. So I need to know the work definition, that is work is done when a force moves an object in the direction of the force, right? So when I apply a force to the object, this is the object in the sense I'll keep. So when I apply a force like this, object will move in this direction, then I can say work has been done. If you push or pull something and it moves, you are doing some work, will say. Okay, you are doing some work, will say. So first thing, you are applying force, and object is moving in the direction of the force, right? In the direction of the force, Second thing, like second point, what they said, either it can be pull or push, and something it's moving, we are doing some work, will say. So something is moving, so we'll consider it's an object. So when something is moving, in the sense we'll say work has been done, right? Yeah. That's the definition, like the simple definition will say. Okay. So the next thing is, what is kinetic energy? Like kinetic energy and potential energy, two energies are there, we'll study in the physics, right? So potential energy, will say it's a stored energy. That stored energy will be used as a kinetic energy, no? Like kinetic energy is the energy of an object as because of its moving. Like when it's moving, we'll say the energy is a kinetic energy. Okay, keep in mind, work is done when a force is applied and object is moving in the direction of the force. Second thing, it can be either push or a pull. Okay, and the kinetic energy, so kinetic energy is the energy when object is moving. Okay, the faster something moves, the more kinetic energy is. Like we know the formula, no? Kinetic energy, the thing why they have said the last point, the faster something moves, the more kinetic energy. So kinetic energy is equals to half mv square. If velocity increases, kinetic energy increases, that's why. Okay, yes. Yeah, that's the, yeah, that's the major difference between the kinetic energy and potential energy. Okay, we'll go to the next thing. So we can write the first point as what is work, and the second point what is kinetic energy. Okay, so 2 points has been completed now, and then I need to know about the formulas, like what is kinetic, work done. Work done is nothing but formula. First we have written the points, but I need to write the formula as well as the SI unit of the work as well as kinetic energy. So under that work, first thing I need to write what is work. So first point has been completed, the definition has been completed. The second point is formula. So formula is work done is equals to force F dot S. F is like where F is nothing but force and S is the displacement. We will say displacement, we will say, right, displacement, right. Okay, it's visible right now. Okay guys, I have adjusted the camera now, it will be visible properly. Okay, so I can write this as Fs cos theta also. Okay, so first point has been completed, second point is formula, and the third point is SI unit. So SI unit is joules, right? Joules will say, joules. Our CGS unit is erg, will say CGS unit erg. Okay, so first point I'll write the definition. In the previous slide I have told about the definition. The second one I'll write as a formula, that is work done is equals to F dot S, which is nothing but Fs cos theta, where F is the force and S is the displacement and theta is the angle between the force and the displacement. Okay, and SI unit is joules and then CGS unit is erg. This is about work. Next, if we see about what is kinetic energy, no? So kinetic energy also the same thing. The first thing is definition, we have seen in the previous slide, and the second thing formula. Formula is nothing but kinetic. Okay, kinetic energy is equals to half mv square, where m is the mass of the given object, mass, and v is the velocity. So SI unit is, so here also SI unit is joules. And CGS unit, what is the meaning of CGS? Centimeter, gram and seconds, right? What about the SI unit, that is MKs, will say, right? Unit is urge. Okay, so this is about the first 2 points you should remember when they ask the question. Develop the notation of the work as well as the kinetic energy and show that it leads to work energy theorem. Okay, first thing we completed, what is work, and the second thing is kinetic energy. Okay, next thing, yeah, it's defined as the dot product of force vector and the displacement, the same thing I have told, and the product of the component of the force in the direction of the displacement. Okay, either you can write these 2 points or else whatever the point I have told previous slides, no, you can write those points also. Okay, so kinetic energy, it is the energy possessed by the body by virtue of its motion. Like the moving object, no, we will say the moving object will have energy, that energy is said to be a kinetic energy, we will say. Okay, so work energy theorem. So first point is work completed, second point is kinetic energy completed. Under that, work definition has been completed, formula has been completed, and SI unit also has been completed. Similarly for kinetic energy also. Now if we see for work energy theorem, so the change in kinetic energy, like kinetic energy we know, but the change in kinetic energy, final kinetic energy minus initial kinetic energy, no, is nothing but work energy theorem. So the change in kinetic energy of a particle is equal to the work done on it by the net force. So consider, like we will see the proof. So this is the thing you should write in the third point. First point, second point completed, third point, this is the thing, work energy theorem. Okay, and the proof, if you want to see, like consider a particle of a mass m moving with initial velocity. So if I consider this is the mass m moving with initial velocity u and same mass m moving with the final velocity v, what is the work done by it if they are asking? So I need to derive it, no. So first thing, we know the kinetic equations, right? Kinetic equation, the kinematic equations, kinematic equations. Okay, that is v square minus u square equals to, wait a minute, I'll write it here. So v square minus u square equals to 2as, one of the equation, and v is equals to u plus at, and then s is equals to ut plus of at square. So 3 kinematic equations are there. No, we know, no. So in that, consider this equation, v square minus u square equals to 2as. Consider this equation. Take that equation simply, like draw the diagram, initial velocity with mass m, final velocity of mass m. Let it have a constant acceleration a. Okay, with constant acceleration a. So after covering a distance s, so this is the distance, we will say. This is the distance s or displacement. It becomes v, velocity becomes v. Initially u, finally v. Okay. Now I will consider the equation, one of the kinematic equation, v square minus u square equals to 2as. Now multiply 1 by 2m, 1 by 2m in both sides, what I will get? 1 by 2 m v square, right? Or else I will consider 1 by 2 m of v square minus u square is equals to 1 by 2 m of 2as, right? This is the thing we need. Now what I can do, I can multiply this one inside, no, I can multiply now. 1 by 2 m v square minus 1 by 2 m u square should be equals to 1 by 2 m of, that is, I mean, I can cancel 2 here, no, 2 1 2 I can cancel it out, m-a-s. Now if you notice here, no, notice here, what is the formula for kinetic energy of mv square, right? So if you notice here, this is u is initial velocity, v is final velocity. What about the formula here? kinetic energy. So this will be my final kinetic energy and this will be my initial kinetic energy. Okay, so this is the note point, you can note it. Okay, okay, so this is my kinetic energy, that is final kinetic energy minus kinetic energy, no, it's initial, should be equals to, so mass into acceleration. Okay, I'll write in bracket only as of now, into yes, mass into acceleration. What is the formula? Force, formula for the force, like mass into acceleration. Am I correct now? So I can extend now. So this is the proof I am writing. Okay, proof. Next thing, if I see here, this is my kinetic energy of final thing minus kinetic energy, initial kinetic energy is equals to m into a is nothing but force into s. So we know the formula for work done. Work done is equals to Fs, that is force into displacement. So final kinetic energy minus initial kinetic energy should be equals to work done. So we got the final formula, no, by using the kinematic equations. By using the kinematic equations, we got the formula of work energy theorem, like change in kinetic energy of a particle, that is final kinetic energy minus initial kinetic energy is equals to work done. This is the thing we need. So guys, like listen, I'll tell you once again, if the question is asked, this question is asked, you need to write the first point as work. What is work done? Okay, so the definition of the work, formula, SI unit. Second thing, kinetic energy. Similarly, so what is the kinetic energy? Definition, and then formula, and then SI unit. These two has been completed. Next thing is what is work energy theorem, like change in kinetic energy minus, change in kinetic energy is equals to work done, we'll say. Okay, so I need to prove that how it is possible. Okay, so that's why we have taken the thing, proof, right? So v square minus u square equals to 2as, that is kinematic equation we have taken and we have proved that, right? So multiplying 1 by 2 m in the both side, that is half m into v square minus u square is equals to half m into 2as. So we got the final answer. This is the final answer. Okay, we'll go for the next question. I hope you got cleared about the question, first question, whatever we have discussed now. Yes, right? Can we go for the next question? Yeah, fine. We'll go for the next. Second question. What are collisions? Explain the possible types of collision. Develop the theory of one-dimensional elastic collision. Okay, the same thing, guys. I need to follow the same thing. So what is collision? First of all, I need to know. Second thing is the types of collision. First point, I need to write a collision. I will write here. First point is what is collision, I need to write. Second one is types of collision. Types of collision. Third one, develop the theory of one-dimensional collision. This is the thing. Okay, so I need to prove that. Okay, I need to develop a theory of one-dimensional collision. That's the thing. So first thing is collision. Collision is an energy interaction between the particle when two bodies comes in contact. Okay, when two bodies comes in contact, we'll say, even without a contact. It can be contact without a contact, provided there are no other external forces acting. That's the meaning of collision, guys. Okay, the first thing, first point you need to write, collision is an energy interaction between the particle when two bodies comes into contact, provides there are no external force are acting. Second thing is types of collision. So there are two types of collision. You can write like this also, types of collision. Types of collision. So first thing, this is the first one and the second one. So first one, elastic collision. Second one is like inelastic collision. Under elastic collision, collision in which momentum, like when momentum and kinetic energy are conserved, no, we'll say it's a elastic collision. When momentum is conserved but kinetic energy is not conserved, right? So 2 points you need to remember, 2 points you need to remember in mind. So whenever we talk about a collision, kinetic energy and momentum takes place, momentum will be there. When both are conserved, I'll say it's a elastic collision. When momentum, only momentum conserved, I'll say it's a inelastic. Okay, you can draw a like a tabular column also, or like the splitting table also. Okay, you need to analyze that, like whether you can write like this or like this, anything is fine. Okay, so a collision in which both momentum and kinetic energy is conserved, I'll say it's a elastic. When only momentum is conserved and kinetic energy is not conserved, I'll say it's a inelastic collision. These are the two types. Now I need to develop a theory for what is the thing for elastic, one dimensional elastic collision. Okay. So consider two bodies, like two bodies I need to consider, which is of mass m1, mass m2, which is moving with velocity u1, this is u2. Okay, so by analyzing the, like taking a diagram, and I can write the own points. Consider a object of mass m1, m2, which is moving with velocity u1 and u2. Okay, and then after, like it will go elastic collision, like they are going into the collision, no. So this is before collision, we'll say before collision. So after collision, no, like in collision, during collision, we'll say this is m1 and this is m2. During collision. Okay, during collision. So after collision, velocity u will become v, right? So this is my m1 moving with v1, this is my m2 moving with v2. This is after collision. Okay, so before collision, this is during collision, and this is after collision. Okay, so u1 will be my initial velocity, u2 will be my initial velocity of m1 and m2, v1 and v2 are my final velocity of m1 and m2. Okay, now we know that elastic collision, right? Momentum and kinetic energy are conserved. So total momentum, this is the thing we know. Keep in mind when elastic collision. First one is total momentum before collision. Should be equals to total momentum after collision. Like conserved, meaning of conserved is nothing but whatever before collision happens, the same thing should be equal to after collision, right? So total momentum after collision. Okay, so momentum formula, mass into velocity. So m1 u1 plus m2 u2 should be equals to m1 v1 plus m2 v2, right? Now here no, m1 is there, mass, I will take one side, and m2 on other sides. m1 u1 minus m1 v1 should be equals to m2 v2 minus m2 u2. Okay, so m1 I can take commonly outside, u1 minus v1 is equals to m2 commonly outside, v2 minus u2. So let me consider this is equation number 1. As of now you have got cleared about this, right? As of now you have got cleared about this. Now the kinetic energy, momentum has been completed. Now the kinetic energy, like total kinetic energy before collision, total kinetic energy after collision. So total kinetic energy before collision should be equals to total kinetic energy after collision. That's it, no? Then it's easy, which is nothing but half m1 u1 square plus half m2 u2 square should be equals to half m1 v1 square plus half m2 v2 square. See here, half, like I can take the half commonly outside, I can cancel it out, right? So I'll go for the next page, right? Or let me move this one. Okay. So half into m1 u1 square plus m2 u2 square should be equals to 1 by 2 into m1 v1 square plus m2 v2 square. So 1 by 2 got cancelled. This one will be m1 u1 square plus m2 u2 square. See guys, I am teaching from the basics. I am teaching from the basics for the IPE students. Whoever are not listening, look, try to listen properly, guys. Okay, wait a minute. Camera, I'll adjust it. Sorry for the disturbance, guys. Yes, I get it's got clear. Fine. Okay, I guess it's fine now. Okay, listen. So should be equals to m1 v1 square plus m2 v2 square. Okay, see, no need to hurry. Okay, like go step by step. If you miss any one variable, no, you will suffer at the last while doing the calculation part. Okay, so go step by step as possible. Okay, now m1 similar thing, m1 u1 square minus m1 v1 square should be equals to m2 v2 square minus m2 u2 square. Okay, now here again I can take m1 commonly outside, which is nothing but m1 u1 square minus v1 square, m1 of u1 minus u1 minus v1 should be equals to m2 of v2 square minus u2 square. Correct? No? Yes. Okay. So let me consider this is equation number 2. Okay, so equation number 1 we got, equation number 2 we got. Now what I'll do, first thing, from equation 1 and 2 equations we got. So from equation 1 and 2, let me consider 2 divided by 1, equation 2 divided by equation 1. What is equation 2? m1 of u1 square, right, m1 of u1 square minus v1 square should be equals to m2 of v2 square minus u2 square. Okay, divide by, what is first equation? m1 of u1 minus v1 should be equals to m2 of v2 minus u2. Am I correct? No. Now m1 m2 got cancelled out. So we know the formula, no? A square minus b square should be equals to a plus b into a minus b. This is the expansion of the formula of a square minus b square. So this one I can expand, no, u1 plus v1 into u1 minus v1 divided by u1 minus v1 should be equals to v2 plus u2 into v2 minus u2 divided by v2 minus u2, right. So here u1 v1 u1 v1 got cancelled out. Similarly in this side also, so left out u1 plus v1 should be equals to v2 plus u2. Okay, so take initial velocity one side and final velocity another side. So or consider this is equation 3. Let me consider this is as the equation 3. So up to now we got equation 1, equation 2. From those two equations we got equation 3. Okay, I need to find the velocities, final velocities, right? How much it has been taken place. So let me find that velocity to find v1, okay. To find v1 in the sense I need to use the first equation. Let me consider the first equation here. What is the first equation? m1 of u1 minus v1 is equals to m2 of v2 minus u2. Okay, this is the first equation. Okay, now in this equation if I want to find v1, what should I eliminate? Initial velocities they have given, I need to find the final velocity. If I want to find v1, I need to eliminate v2, right? So let me take the equation 3 and write what is v2 here. So from equation 3 v2 is equals to u1 plus v1 minus u2. This is my v2, okay, this is my v2. So equation 4. So equation 4 in substitute equation 4 in equation 1, right. This is the equation 1, right. This was the equation 1. So substitute the equation 4 in equation 1. What I'll get? m1 of u1 minus v1 is equals to m2 of what is u1, I mean what is v2 here? u1 plus v1 minus u2 again, okay, minus u2. That's it. That's the v2 value I have substituted in equation 1, okay, equation 1. So if I expand, no, m1 u1 minus m1 v1 should be equals to m2 u1 plus m2 v1 minus 2 times, this is minus 2 u2, no, 2 times m2 u2, okay. This is the things, guys, this is the thing. In this equation I need to find v1, right. So consider v1 in one side, remaining terms in other side. So m1 u1, take this m2 u1 minus m2 u1, this one plus 2 m2 u2 should be equals to m1 v1 m2 v2, m1 v1 plus m2 v2, sorry m2 v1, sorry, it's m1 v1 plus m2 v1. Now in this, no, I can take v1 commonly outside, m1 plus m2 should be equals to, this is the thing, no, u1 commonly outside, right. So m1 minus m2 plus 2 times of m2 u2. So which is equals to v1, keep v1 one side, remaining terms, u1 of m1 minus m2 plus 2 m2 u2 divide by m1 plus m2. This is my v1, guys, that's it. This is my v1, this is my v1. What about v2? So see here, in this I need to find v1, I have taken v2 as the elimination. So to find v2, no, similarly to find v2, what is the equation? See here, similar, I will write in this case. To find v1, we have taken. After completion of this part only you should go for the next part. Okay, here to find V2, so I need to consider eliminate V1 from the equation 1. So from equation 3 I'll write that also. From equation 3 V1 means should be equals to V2 plus U2 minus U1, right? V1 keep one side, remaining term other side, V2 plus U2 minus U1. So this is my equation 5. Okay, equation 5. So what we got? Equation 4 we got. Now equation 5 we got. Substitute equation 5 in equation 1. Equation 5 in equation 1. What is equation 1? It is m1 of u1 minus v1, m2 of v2 minus u2, right? Okay. So m1 of u1 minus v1 is equals to m2 of v2 minus u2, right? So what is v1? Substitute here. m1 of u1 minus of, okay, minus, let me take in a square bracket this one minus of v2 plus u2 minus u1, close the bracket, is equals to m2 of v2 minus u2. Now if I take the minus inside, minus v2 minus u2 plus u1, m1 of u1 minus v2 minus u2 plus u1 equals to m2 of v2 minus u2. Now substitute m1 in everything. m1 u1 minus m1 v2 minus m1 u2 again this is 2 times of m1 u1, that's it, should be equals to m2 v2 minus m2 u2, that's it. I need to find v2, right? I need to find the v2. Same thing guys, same thing, I need to do whatever I have did here. Take v2 one side, remaining term other side. So 2m1 u1 minus m1 u2 minus m2 u2 should be, I mean this is plus, right? Plus, if it comes this side it's plus. So this one m1 v2 plus m2 v2. So here I'll leave as it is this one, u2 I'll take commonly outside, that's it. m1, I mean 2 times of m1 u1 minus, so I'll take this is plus only of u2 m2 minus m1, that's it, m2 minus m1 should be equals to v2 of m1 plus m2. So now v2 will be equals to 2m1 u1 plus, this is u2, right? u2 of m2 minus m1 divide by m1 plus m2, that's it guys. This is the final answer. Guys for the question. It's a lengthy question, huh? Simple question. If you get this question, sure shot you can easily write it. Only one thing you need to remember, momentum and kinetic energy has been conserved. Momentum formula, kinetic energy formula. So total momentum before collision, total momentum after collision. Similarly, total kinetic energy before collision, total kinetic energy after collision. So when you remember these two things, momentum and kinetic energy, the total thing I can write it, right? This is the total derivation. So momentum and kinetic energy are conserved. Okay. So this is the thing. So you can copy down or you can take a screenshot of this. You can note everything. This V1 formula and this V2 formula. So when I need to find V1, eliminate V2 from equation 1. When I want to find V2, eliminate V1 from equation 1. Okay, that's the thing you need to remember. So this is about the second question. Okay, hence proved V2 and V1 we got. The next question is, yes, State and prove law of conservation of energy in case of a free falling body. What is the meaning of free falling body, guys? When I throw an object, like not a throwing, when I leave an object simply like this, due to gravity it will go down. Okay, I am not applying any velocity or any force on that. Okay, so it's falling freely from top to bottom. So first thing, the similar thing. Okay, I need to find, yes, where is this? Yes, pen. Okay, I need to know what is the law of conservation of energy, first thing. Second thing, I need to prove that free falling body, okay, energy is conserved. So law of conservation of energy can neither be created nor be destroyed. It can be changed from one form to another form, right? So total mechanical energy of the system remains constant. So this is the thing I need to prove. So this is the 3 points I need to write properly. After that, the proof. So for proof, no, consider an object freely falling, like consider an object which is freely falling. Okay, suppose let me consider an object A, object of mass m, of height, okay, this is the height, I'll consider this is the height h, capital H. So at the point A, this is at point B, mass will be same, no, at point B this is point B, in the sense from A to B the distance has been travelled, let me consider as x. Okay, the distance has been travelled, let me consider as a x. So this is point B, let me consider point C also, point C. So the remaining distance, what will be the remaining distance? Total distance or height is h. So from point A to B it is x. So remaining will be h minus x, which is nothing but small h will consider. So this is the thing you need to write first thing. Okay, write the first. Now energy, mechanical energy, they said no, mechanical energy, right? The first thing has been completed. Now at point A, kinetic energy, so of mv square. See, I will write that also here. Here at this point h will be equals to 0. Total height is not there, h is equals to 0. The surface, no, I will write surface, this is the surface. So initially v is equals to 0, initial velocity is equals to 0. Okay, now where is the thing? Yeah, move. Now of m into 0 square, which is equal to 0. Now potential energy mg h, what is the total height? Mg capital H. Now total mechanical energy they are asking, no, mechanical energy is nothing but potential energy plus kinetic energy, which is equals to mgh plus 0. The final will be mgh at point A. This is about point A. Now what about point B? I will write point B. At point B. So point B, can you analyze this? I'll move little bit up now. So can you analyze what will be the height? What will be the height there? What will be the height? Yes, obviously its height is h minus x. Like the thing, no, many people observe that height will be x. No, I am taking potential energy means what? When it's in the surface, I am taking that surface, object at the height h. Okay, it means it is travel h minus x height. At the height, this is the height. So how much height it has been there, how much distance it is not traveled, how much height the object is there, the meaning of potential energy, right? So wait up, yes, I'll write here. First thing, potential energy. Potential energy should be equals to mgh. This is A, height A. This is height B, which is equals to mg of h minus x. H minus x. Okay. Now, if I expand this, mgh minus mgx. Okay, this is my potential energy, guys. Now, what about the kinetic energy? Kinetic energy should be equals to of m vb square. This is va square, right? This is vb square. Now, I need to find the velocity. One thing I know, v square minus u square equals to 2as. Equation I know, no? From this equation, initial velocity is 0. Initial velocity is 0, right? What about the final velocity? Vb square equals to 2a. How much distance it has been travelled, guys? Here, if you notice here, that is, yes, that is displacement. We'll say displacement, right? Displacement. So I can write now. This is x. So substitute the value of vb square here. So kinetic energy is equals to of m into 2ax. 2ax. And when object is falling in this direction, a will be equals to g. A will be equals to g. So 2 will get cancelled. mgx. mgx. This is my kinetic energy. Now, what is the total energy? That is mechanical energy. Mechanical energy is equals to potential energy plus kinetic energy. So, potential energy is mgh minus mgx plus mgx. So, mgx minus mgx cancelled out. So, the final answer is mgh. This is mechanical energy at A, this is mechanical energy at B. So, I have got mgh, here also mgh, right? Now, I need to find for point C, right? What about point C? So, here velocity will be, here this is VB, I will say, this is VC, VC. Here height is 0. Height is 0 in the sense potential energy will be 0, right? So, point A, point B completed. Point C. At point C, potential energy is equals to mgh, height C. So, where hc is 0. So, potential energy will be 0. What about the kinetic energy? Kinetic energy should be equals to of mvc square. So, similar, guys, v square minus u square is equals to 2a, yes, okay. In this, initial velocity is 0, final velocity vc square is equals to 2g, the total displacement is h. From top to bottom, how much distance it has been travelled? Height h, no? So, substitute the value here. So, of m 2gh, where m, I mean, sorry, m not, it's m not cancelled. 2 and 2 get cancelled, okay? So, mgh will be remaining. Now, mechanical energy will be equals to potential energy plus kinetic energy, where potential energy is 0, kinetic energy is mgh. So, final thing for mechanical energy at point C, mgh. Hence, proved. So, energy, I will write the thing, final thing, total. This is the point you need to write when you complete the 3 equations, okay? Total mechanical energy is same at point A, B and C, which is mgh, no, that's the thing you need to conclude, okay? This is the thing you need to conclude at the last. Total mechanical energy is same at point A, point B and point C. Hence energy is conserved. Yes, that's the thing you need to write. Energy is conserved. Okay. I hope you enjoyed the class, guys. Like IPE class, right? Work, energy and power. Okay. So these are the three important questions you need to revise it. Okay. See, why I have shorted why I have shorted IPE? The main reason is we will cover everything, IPE, NEET or JEE mains or MSET. Okay. You need to cover simultaneously everything. At last, no, if you dump everything at the last, it will go in, it will not go inside, right? So complete the questions as early as possible. That's the thing. Okay. No need to mug up this one, like no need to write and see this one. Try to understand what is the question they are asking. Once you try to understand the question, right, you will write the answer by your own. You will get the derivation accordingly. Okay. So no need to worry about IPE session also. I will take care of that. I'll teach complete IPE inter of 11th and 12th. Okay. So one class will be 11th, next class will be of 12th, like that we'll cover. Okay. No need to worry, guys. So let me conclude this class up to this. Okay. We'll continue with the next session. So stay tuned, guys, for the IPE session 2, and we'll start with the 100 days challenge also. Like we have started, no, we'll continue with that also. Continue with 100 days challenge and questionnaires. Like NEET questionnaires has been going on. Once NEET questionnaires has done, no, we'll go for the JEE mains question. Like initially we have started with MSET questions, right? So next we'll start with JEE questions also, that is previous year questions. Okay. I hope you enjoyed the class, guys. So we'll stop up to this. Bye bye.